Hello, welcome to my channel. We have been solving this past exams, past question papers. So right now we are doing this May June 2025 version 41, and this is mathematics or mechanics. So we have solved first five questions. You can check my previous videos. And today we will be doing the last two questions, question number 6 and 7. Okay, so you can see this solution in the previous videos, and we will do question number 6 today. Okay, from here. Okay, so the scenario is that we have two weights. This is zero point 0.3 kilogram, this is zero point 0.6 kilogram. They're both on some inclined surface. The surfaces are frictionless. We assume this angle is theta, not known to us, and this angle is 30 degree. Okay, so the two particle PQ message this respectively are attached to this around this. Okay, we need to find the tension in the string and the acceleration of these objects. Okay, so let's assume that they are moving in this direction. Okay, because Q is heavier than P, so I just assume that it's going in this direction. Okay, so if you see this object P, what forces are working on it? So this is the force of tension in the string, right? The downward force, this is, if you remember, it is mg sine theta. Okay, so these are the two forces acting on this object. So the difference of this force is the net force, and that net force is causing an acceleration in this direction. Okay, so if I analyze this way, so I'm assuming tension is larger because it's going upward. So this tension minus mg sine theta, this is equal to ma, where m is the mass of this p. Okay, so in this equation, if you see, I know everything except p and a. So these are the two unknowns, and I have to work with this. So T minus mass is zero point 0.3 kg, G I'm using as 10, and sine of theta, theta is not known, but the sine of theta is given as zero point 0.4. So times 0 0.4 equals M is again 0 0.3 into A. Okay, so this all will simplifies to uh, um, it all simplifies to T minus 1.2 equals 0.3a, right? Okay, now look at the second object, Q. This uh, Q, it has one downward force, which is mg sine of 30 degree, right? This angle is 30 degree. And the upward pull is the tension, same tension which is in this string. And that is causing it to slide down with the same acceleration a. So if I apply all these things here, it comes out to be mg sine 30 degree minus t equals ma. But in this expression, this m is 0.6 kilogram. Previously, in this equation, the m was 0.3 kilogram. It was applying on this equation, on this mass. Okay, so this m is zero point 0.6, g is 10, sine of 30 degree is 0.5, minus t equals m is zero point 0.6 into a, right? So this all will be simplified into 3 minus t equals 0 0.6a. So now I have two equations and two unknowns. I will solve them and try to find the value of a and t. So you can see from the first equation, uh, t is equal to 1.2 plus 0 0.3a. Let me substitute this value of t in the second equation. So 3 minus 1.2 minus 0.38 equals 0.6a. So if I take it on the other side, so 3 minus 1.2 equals 0.6 plus 0.3 into a. Okay, and this will give me the value of a as 2, because yeah, 3 minus 1.2 is 1.8. 1.8 divided by 0.9. So this is equal to A, which is 2 meter per second squared. Easy. Now from this value of A, I can find the value of T. So you see T is equal to 1.2 plus 0.3 A, which is 1.2 plus 0.3 into A is 2. So it is going to be 1.8 Newton. 1.8 Newton. Okay, so we have to find the value of tension and the acceleration. So we found the tension and acceleration over here. Okay, easy. Now let's do part B of the same problem. Now it is given inside that the plane BC is rough. So remember, we have this scenario. Uh, this angle is theta and this angle is 30. This point is A, B, and C. So this plane is rough. Okay, so it has some friction. Okay, the work done against the friction force when Q moves 2 meter down, the plane is 1.8 joule. So it moves 2 meter down, and the work against the friction was 1.8 joule. Okay, we should assume that P does not reoccur at this line. Use an energy method to find the speed of Q when it has moved 2 meter down the scale. Okay, so when Q was here and P was here, this is P, this is Q, right? And system was stationary. Okay, so there was no potential kinetic energy in the system. Now this P moves 2 meter down the slope. Okay, so it has lost some kind of potential energy, right? And that loss of potential energy is equivalent to gain in the potential energy of P and the kinetic energy of the system and the work done against the friction. Okay, all is coming from the loss of potential energy of Q. So loss of potential energy of Q, potential energy of Q, this is mgh, mg, and h in this case is going to be 2 times sine 30. Does it make sense? Because 2 is this length around the slope, and angle is 30. 2 sine 30 is the vertical distance it has lost the height, right? Okay, so the mass is 0.6 kilogram and G is 10, and 2 times sine 30 is 1 because sine 30 is 0.5. Okay, so this all comes out to be 6 joule. Okay, so this is the loss of potential energy of object Q. Okay, now what is the gain of potential energy of P? Right, we have gained some height. So again, we will apply mgh. M is 0.3 kilogram, G is 10 meter per second squared, and H is 2 sine theta, right? Because if this has gone 2 meter down, then P is also going 2 meter up, but the vertical distance it has taken is P is 2 times sine of theta, right? Okay, so 3 times 10 is 0.3 times 3, and this is 2 times sine of theta given as 0.4. Remember? So this is going to be 2.4 joule. Okay, this the energy loss is 2.4 joule. Yes. Okay. Now, uh, so see, remember I told you that the potential energy, the loss of potential energy of Q, right? This is equal to gain of the potential energy of P plus the work done against the friction, which is 1.8 joules. Okay. Uh, Plus the kinetic energy of both objects, right? So that is going to be half, and their masses are zero point 0.3 plus zero point 0.6, and assume the velocity of these objects is v, so this v square. Okay, I hope this expression is clear to you. This is very important, that the loss of potential energy of object q, it is equal to the gain of the potential energy of p plus the work done against the frictional force plus the kinetic energy of both the objects which are moving now. Okay, so we will simplify this expression and find the value of V from here. So potential energy of Q was 6. So 6 equals potential energy of P is 2.4 plus 1.8 plus zero point 0.6 plus zero point 0.3 is zero point 0.9 over 2 V squared. Okay, so this is going to be 0.45 V squared equals 6 minus 2.4 minus 1.8. So V is going to be 6 minus 2.4 minus 1.8 divided by 0.45 and into the root. Okay, so this it comes out to be 2 meter per second. Okay, I hope it was all straightforward. I hope you enjoy this question. Now, um, okay, yes. So let's do question number 7 now. Okay, yes. So a particle X moves along a straight track starting from a point O at the time 0. There's displacement of X from the given like this. Okay, so we are talking about particle P. Okay, and we are given that distance or displacement as a function of time is given as 3t to the power 3 by 2 minus 60. Okay, so we are given the displacement as a function of time. Now you see, find the time at which the x is instantaneously at rest. We need to find the time at which this displacement was at rest. The speed was 0. Now, knowing the distance, how can we find the speed? Speed is the derivative of distance, remember? So, I need to differentiate this expression. It is going to be 3 into 3 by 2 t to the power 3 by 2 minus 1 is 1 by 2 and minus 6. So, it is 9 by 2 is 4.5 t power half minus 6. This is the expression for the speed as a function of time. Okay, now we need to find the time when the speed was 0, right? Okay, we find the time at which the it's not that rest, yes. Okay, so the if the speed is 0, we have 4.5, and this is under the root t basically minus 6. So from here you can see that t under the root equals 6 over 4.5, and What is 6 over 4.5? It is 4 over 3. And from here, t is equal to the square of this part. This is 16 over 9. Okay, which is 1.8 second. So it shows that at 1.8 second, the object, this particle x, it was instantaneously, it was at rest. Its speed was 0. Okay. And hence find the total distance traveled by x between 0 and t16. Okay. Remember at time 0, s0 was, if I substitute t equal to 0, it is 0, right? And the distance at time 16, okay, this is equal to, I just need to plug in the values here, 3 and 16 power 3 by 2 minus 6 times 16, okay. Now 3 and 16 square root is 4 and 4 power 3 is 64. 64 minus 6 times 16. So this all comes out to be 96 meter. Okay, so this was part A of this problem. Okay, so let's move on to part B now. Okay, a second particle y moves along another straight track starting from a point P at time 0. The acceleration of y at time t is a. Okay, so in this case, now we are talking about particle P. P or what? Before, sorry, not P, it was X. It started, yeah, why did I say P? It is particle is X. So this all analysis was for X. Okay, now we want to do for Y. So for particle Y, we are given the acceleration. Okay, so the acceleration is given as 0.8 minus 0.6 t. Okay, okay, the velocity of, yes, and we are given that the velocity when of the velocity at time 0. Okay, the velocity of y when it leaves P, so that was 7.5 meter per second. This is also given to us. Okay, so remember that acceleration is basically the derivative of speed, right? So from here we can find the speed by integrating it. Okay, so the speed is equal to 0.8 minus 0.6 t, and we will integrate it with respect to t. Okay, so this integral will give me 0.8 t minus 0.6 t squared by 2 and plus a constant of integration, right? So it is, let me write it again, c plus 0.8 t minus 0.3 t squared, right? Okay, now at time 0, right? At time 0, the speed was 7.5. So when time is 0, speed was 7.5. So on the right side, I have c plus, this will become 0, this will become 0. So the value of c is 7.5. So now I can see that the velocity as a function of time, it is equal to 7.5 plus 0.8 t and minus 0.3 t squared. Okay. Now Again, they are giving us that when the velocity of y is minus 9.6 meter per second, show that the displacement. Okay, so we need to know that at what time the speed was 9 minus 9.6 meter per second. Okay, so the speed is given as minus 9.6. So I have to solve this equation for the value of t. At what time this speed was minus 9.6 meter per second. Okay, if I bring everything on the left side, it is 0.3 t square minus 0.8 t. And when I add these two things together, because when 7.5 go to the negative side, left side, it becomes negative again. And they're both together, it become minus 17.1. Minus 17.1 equals 0. Okay, now this is the quadratic equation. I need to solve it. Let's use the quadratic formula. So t is equal to minus b plus minus under the root b square, so 0.8 square minus 4a, and c is negative, so it becomes plus and 17.1 and divided by 2a is 0.3. Okay, and when we simplify this thing, it gave us two answers. One is 9, and the other answer is minus 6.33. Of course, this is not reasonable answer, so we will use the time as 9. So at 9 seconds, the speed was minus 9.6 meter per second. Okay, but my question was that show that the displacement of x from O is equal to the displacement of y from B. So I need to find the displacement of y at this instant. Okay, so I know the velocity, it is given as, remember, 7.5 plus 0.8 t minus 0.3 t square, and the velocity is basically derivative of the distance or the displacement, right? So from here we can guess that this displacement is equal to integral of 7.5 plus 0.8 t minus 0.3 t square and dt. So this integration is simple. It is 7.5 t plus 0.8 t square by 2 minus 0.3 and t cube by 3 and plus a constant of integration that we call it k this time. Okay, so this s is equal to this constant plus 7.5 t plus it will become 0.4 t square minus 0.1 t cube. Okay, but now we are given that displacement was 0 at time 0. Remember, we are told that at t0 the particle y, it was at p, so the displacement was 0. Okay, so at time 0 everything is 0, so s at 0 is 0. So this is equal to k plus 0 plus 0 plus 0. So it means k is also 0. And my distance as a function of time comes out to be 7.5 t plus 0.4 t square minus 0.1 t cube. Okay, now we are in a position to answer our question. We have to find the displacement of y from P at this time. At what time? When time was 9. Okay, so let's find the distance at 9. So this is 7.5 times 9 plus 0.4 times 9 square minus 0.1 times 9 power 3. And when we did all this calculation, it gave us 27. So this was for y, remember? Now let's calculate the for x, the distance at, at 9. And remember, we have to use this expression. Which one? This one. 3, it was given to us 3t, 3 by 2. It was 3t power 3 by 2 minus, I believe, 6t. Let me double check. Yes, minus 60, so minus 69. Okay, so you can see this is 9 square root is 3. 3 power 3 is 27. So this 3 times 27, this is 3. And minus 6 times 9. And this is also simplified to be 27. Okay. So that proves that both the particle have same displacement at 9 seconds. Okay, I hope you enjoyed these solutions. If you ever have any question, you can always ask me in the comment section. By the way, I hope these videos are benefiting you guys. And if it is benefiting you guys, then I will request you to subscribe my channel. That will benefit me as well. Thank you very much for watching. See you in the next video.